Hello everyone, welcome. Azure Functions, the easy way to an API. This will be so much fun to talk about. Before we get going, huge thanks to our sponsors. They're doing awesome work. Without them, we wouldn't be here. They're paying for all this fun, so thank you everyone once again. A bit about me, you can find me on the outer net. I'm Björn, Sundling. I'm an MVP and MCT and a whole lot of other stuff. I do DevOps and Azure consultancy at a consultancy company called Advania in Sweden. We do lots of cool cloudy stuff. And you can find me on the internet, mastodon.nu @Björn, most likely, GitHub and so on and so forth also. Basically, if you find Björn somewhere, chances are fairly big you've stumbled upon me in that platform. Enough about that. So, what is an API? Good to know before we actually deploy them, right? API is short for Application Programming Interface. And in contrast to a user interface, a GUI, which they talked about here just seconds ago, an API is, I was supposed to have clicked that. There we go. An API is made for communication between computers, which means we don't have to care about the fancy stuff. We just have to have some kind of structure around it. So structured data is sort of where this all started. Now, an API is basically anything made to communicate between computers. So basically a module could be considered an API. A DLL could be considered an API, whatever. But, so in the early noughts, we came up with something called web APIs because we discovered something back in Web 2.0 era that everything should be online, right? And so they started with, they being W3C, the company that does lots of the web standards. They started with standardizing on a protocol called SOAP, or Simple Object Access Protocol, which is XML based. It has a lot of rules around it, or how you should implement it and so on. And you know, it was kind of weird. So instead, we started doing something else. They sort of decided we need to do something easier, so more human accessible. So they came up with a new standard called REST, or represented REST. They came up with REST, which is a stateless protocol, basically based on web stuff. So a RESTful API is what it's called. Basically has to implement standard web calls such as posts and gets and options and so what, the stuff we already have. They decided to go for JSON because JSON is, well, you can do it with a schema, but it's basically schemaless, so you can do whatever you want to. And it's way easier to actually implement a REST API because it sort of works the way we want it to, the way we expect it to. And the reason for all this, why we started doing web APIs, or actually we kind of use web APIs and APIs interchangeably by now, so a lot of the times we just say I'm creating and deploying an API, whereas technically it's a web API. But the reason for this, of course, just like when we create functions or modules, is to hide the details. Our users will not care what happens behind the scenes. They say, okay, if I post this body containing of new user data, a new user will show up in my system in the backend. I do not care what goes on in between. And so we have an API, two machines or two machine integrations talking to each other. So with this knowledge, what is an Azure function and how does this map into this? Well, Azure Functions is, my clicker ran out of battery, so I have to go here and do this. Yeah. Azure Functions is Microsoft's serverless computing for Azure solution. Now, serverless in this case doesn't mean that it's without servers. It just means that we don't care about them anymore. We do not have to sort of set up a machine, make sure it has the runtimes and so on. It basically means you throw your code at it and it runs. I don't care how. This is my code. Just do what you want with it. Make sure that it runs. And Azure Functions solves this by using a sort of tiered structure that you have to set up. And I actually do have slides for it, but slides are boring, so let's go and see if we can. We can't, so let's do this instead. Come on. Thank you. So an Azure function consists of 3 basic tiers. This is a resource group. I hope the scale is enough. If not, please yell at me. Basically, in the bottom, you have what is called an app service plan. An app service plan, well, you could sort of think of as a machine. You set it up, or you create it. You say, this is sort of the size, this is the scale I want of this is how many CPUs I want, and so on. And you get a cost based on it. If we go into my app service plan, there isn't really that much to configure. You can sort of set up scaling, but as you see, it's grayed out. You can do some networking in here, but again, as you see, it's grayed out. The reason for this is that an app service plan comes in different levels. And in my demo here, the pricing plan is set as Y1. This means that this is basically free to use. So we can just go back to this for 2 seconds. Come on. There we go. So when we create this, we're given the option to do a consumption, a function premium, or an app service plan. And basically, this means somewhat different settings for when you create the lowest level, the machine level. The good part about this, the fun part about this, is that the consumption plan is actually doable for most PowerShell stuff, I find. If you have requirements such as private networking and stuff, you have to sort of opt up a bit. But for just creating an API, the consumption plan is actually perfect. It's the serverless plan. And it doesn't cost us anything when we don't run large-scale stuff on it. Sorry. Okay, so on top of the app service plan, the machine level, we have our function apps. And a function app, well, we could think of as a container host. Docker, Kubernetes, whatever, I don't care really what it is behind the scenes. But here's where you do the container level configuration, so you can do stuff like managed identity configurations, or set up custom domains and say that this domain, instead of having bjorn.com running on a GitHub server, you have it running here, and so on and so forth. We also have, come on internet, the configuration settings. This is important to remember because there's a whole lot of stuff going on here. So we can set stuff like, well, say your API has a backend in a SQL server or a database. You can set up this using these kinds of settings instead and don't have to manage it inside your code. You don't have to risk deploying it in your code and so on. And sort of the last level of it all. So we have our computer level. We have our containerization level. Last but not least, we have our actual functions. And this is where the fun begins. This is where your actual code will be running. There's not much to do in here, really. Like, we can look at the code, you can do some monitoring and stuff, but basically this is the part where throw your code at it and it will run comes in. This is your PowerShell code. Throw your PowerShell code at this, and it's done. You don't have to care about the underlying layers. Now, yes, you have to configure some stuff, but anyhow. So, now that we know the structure, of course, you can set this up using a GUI, going add new functions, and so on and so forth. GUIs are boring. We're not here to look at GUIs. So naturally, you can do this in PowerShell, and it's actually quite easy. Wait. That should be enough, I hope. We need to create resource groups. We need to create our storage account because it needs to store our files somewhere. And we can run just new AZ function app, and it will work absolutely flawless. One thing to remember, an Azure function on the app level needs to have a globally unique name. And I don't mean within your organization, I mean totally globally unique. The reason is we're building a web API, it's reachable from the web, need to have it unique. Give it a runtime, we're running PowerShell and so on and so forth. Which operating system, as of when I wrote this, was PowerShell 7.2. It may be newer now, I don't know. But there is an issue here, and that is PowerShell is sort of a stateless language. It doesn't keep track of what's going on. So if I would run this, and I would run this once more, then it will say, this already exists, can't do this. So we'd have to build sort of a lot of try catches, ifs, elses, so on and so forth. So instead, when deploying stuff, I would suggest using something like Bicep. Now, this isn't a Bicep session. I won't go through this as much. But what I can say is this is pretty much stolen from the learned material. This is how you set up an Azure function using Bicep. It's quite straightforward. But I want to highlight, again, you have to say we're running PowerShell, which version, sort of standard settings. But I want to highlight one particular thing here. And this is website content share. Because this is a quirky one. If you download or look at the material, wherever you are, or learn material, wherever from, this setting will be enabled. And I find that most of the issues we have is actually down to this setting. Because it's needed sometimes. If you deploy and then you do an update, and the update doesn't update anything, most likely change this setting and redo it again. So once we have created our Bicep, it's pretty much straightforward. But Bicep is a stateful language, so we can deploy it, we can redeploy it. As long as nothing changes, it should just continue running. We still have to keep track of the resource group, though. But let's see if we can do this. An actual real-life live deployment. Again, the name of the function needs to be globally unique, hence the sort of GUID magic stuff going on up there, because GUIDs are technically almost always globally unique. So we have started our deployment, and that will take a couple of minutes. So while we do this, let's go back and look at some more. There we go. Setting up using Bicep is good. There we go, yeah. Okay, tooling. So we have set up the infrastructure. Now this is basically fast now. We have set up our infrastructure. It's time to start actually doing the deployment. And there is a cool little tool called the Func CLI for Azure Functions. If you're doing development of Azure Functions, I recommend learning the Func CLI, not by heart. I don't know anything of it by heart, but it's good to know that it's there. It's the back end of sort of doing all kind of low-level development. You can use it to run Azure Functions locally on your computer. You can use it to debug stuff locally. So it's a really useful tool, but its entire session just sort of gets started on the Func CLI. So instead, I am going to focus on what is needed inside VS Code. So there's an extension. Naturally, there's always an extension named Azure Functions. Super advanced, super hard to find. If you install this, it will give you access to all kinds of cool... Oh, shit, sorry. So I was told once that I curse too much on stage. Fuck them. There's an extension called Azure Functions. It's really, really good. And you need this, or, well, you technically don't, but you want this when you do Azure Functions development. When you install it, you get, amongst others, this, I hope you can see on the side, I get an Azure button. And this one gives me access to all kinds of cool stuff within Azure. If it doesn't already automatically log you in F1, it's like connect to Azure or something, I don't remember, but there is a keyword for logging into Azure, and it will list your subscriptions here. And if we go look at, yep, the deployment is done. So hopefully we can actually see that it generated a random name and has created my Azure Functions, and it's already live updated in the connection here. Now, inside here, we can see all kinds of cool settings like the app setting. Yep. Sorry? It's okay. So the question is there a limit for the amount of characters for the name? Yes, but I don't remember it. Every single Azure resource has their own scope limit. It's actually quite a lot of discussion going on why they can't standardize on one naming standard. It's documented, go to learn, or we can do it afterwards if you want. You need to be globally unique, that's all I can remember for now. Yeah, so remember I said we have your like app settings. You have your app settings in here. You can actually explore most of the stuff in your Azure function already in here, although it's quite slow, but it works. You also have a workspace window. The workspace window links or shows all your local open workspaces that is identified as Azure functions. Now this is a demo environment, so I already have lots of code. Normally this would be empty, but inside here we have a small button that disappears when I don't, which I hate, but there is a small button in here named Azure Functions, which we can click and do either create function or create new project. A new project means that it will scaffold everything for us that's needed for an Azure function app, including the app settings level, and so on. If you have created a function app, a project, you can just add more functions to it. Because just as your container host can run 1 or 2 or 3 or a million containers, Azure function apps can run 1 or 2 or 3 or 4 or 10 apps. Eventually you will run out of CPU, but that's your fault. So we're going to create a new project for now and hope that it works. Thank you. Of course, we need to pick a folder where to create our project. We need to create a language. PowerShell is just one of the supported language. If you hate yourself, you can do it in JavaScript. But for now, let's go for this. So the first key to this is the trigger. We need to say, how do we want our function to trigger? Now we're building a web API. That doesn't necessarily mean that someone has to browse to it or invoke REST method has to call it. We could actually say that this should be run on a time schedule. Or whenever a new file shows up to our blob storage, trigger this function, do some magic with it. So whenever HR adds a user to our Excel document, trigger this function, create the user, you're done, congratulations, awesome. But for now, let's create an HTTP trigger. And we need to give our trigger a name. This is the actual function name. You can name it whatever. My function, like this. And we can also choose to opt in for authorization. This supports all kinds of like Azure authorization and stuff in different levels and so on. Because time and simplicity, we're just gonna opt not to do this. So what just happened? Well, I hope you can see on the left side of my screen that there's a lot of green files in there and a couple of gray ones. When we create our new project, this will scaffold everything we need for us. Everything including stuff we don't need for us. So it's just going to try to run through all these files quickly, or some of them. You have stuff like funcignore, which is basically a git ignore file for the func CLI. If you use func CLI to deploy or update and run, you need to have this file because otherwise it can get quite dirty. If you don't use the func CLI, remove it. Doesn't matter for the function. You have your host configuration. This is basically what tells us that the configuration we just did, that we're running PowerShell and so on. You have local settings, which is the same. If you're doing local development, you can actually say that while I develop stuff, talk to this storage account, talk to this database. While I deploy it, this is the database we're using. But what's interesting is, if I can find it, this one. So you have something called manage dependencies in Azure Functions. And by default, this is enabled. And this combined with requirement.psd1 allows you to do stuff like, hey, my function needs the az.whatever module. Put it in here and make sure manage dependencies are enabled. And every time your function starts, it will download and make sure that this module is available. Super cool, right? No. This is actually slow as... It's good, it's useful, and you can do it, absolutely, but it's quite slow. So if you don't really want to run latest and greatest or use this, try to avoid using manage dependencies. It works, but I'll show you how to do it in a short while. We also have a profile file. This is just as you have a profile in PowerShell or in VS Code and so on. You have a profile file here as well. You can do whatever you want in it, whatever you need. Set up your profile, your environment the way you want. But most importantly, and most interesting, we have a folder named my function, which coincidentally is the name that I gave my function when we created it a couple of seconds ago. And this is where all my magic happens. It has even scaffolded this for us. So it contains 3 files normally. A function.json and a run.ps1 that we will look at, and a sample.dat that I have absolutely no idea. It's something to do with tests in certain scenarios. I have never seen anyone use it, so I just remove it for now. I'm just going to ignore it, but this file is just weird. Functions.json contains the first half of where the magic happens. This is basically configuring our input and output. Because we're creating an API, it's on the web, it's meant for computers to talk to each other. There is no console. So how do we get input and output from our PowerShell scripts? We use bindings. You can configure 1 or 2 or 3 or more bindings, but by default for a web API, you normally have 1 in and 1 out. So we have a binding direction in that says, this is something we can accept. Remember I said that a REST API, a RESTful API, supports standard methods? Currently, we default to get and post. Those 2 methods are already implemented for us. We have a name for it. Come back to that in a couple of seconds. And like we configured, we said anonymous. We also have a output binding, direction out, that says, well, just as we have no console for people to write parameters, we have no way to return data unless we actually have an output binding, say that the result of this is to output data this way. And we have a name and the type as well here. Now this file combined with the run.ps1 is sort of, this is actually the only difference between standard PowerShell. Because the input binding, we name it request, and we have a parameter in our PowerShell named request. And this means we will already automatically map everything that comes in through any of these types of input to the request parameter. It will be done magically in the backend. So, to see how this looks, well, have anyone ever seen something like this? Invoke REST method. I hope I can spell now. Question mark, name. Something like this. Can highlight it. It's easier to read. There we go. Everything behind the question mark is what's known as a query string. A query string is a absolutely non-standardized weird language, but most commonly we use key value patterns, which means you can do anything here. You can input 1, 2, 3, just separate them by the, is it ampersand? Yeah. And we can do also age equals 43, 40, yeah, old enough. And this will be automatically input into our request. Because we named it request, it will automatically end up as a request and then query, because it's a query string, and the name value, we will have a name property of it. So it's basically PowerShell, but harder to do get member on. And this is because, so this is a way to sort of input data using a GET request. This URI means that we can just put this in a browser and say, give me back whatever. But we also do quite often stuff like this. Invoke REST method, $URI. Let's just do something like this. Method post. And then we have a body. And I would guess it would be something like this. Equals. And then we would do something like to JSON. It's quite common as well. This is the post body. It does more or less the exact same thing, but instead of saying get with the query string, we just say post this content, structured data, it's a JSON, to our web page and see what, or our web API and see what we get back. And just as it maps the query string, it will also map request.body, because request, again, the name we gave our input, and body because it's a body, and name because, well, we gave it the name parameter. So in both these cases, the $name variable will consist of Björn. And I mean, this is basically PowerShell, so it will say hello name, hello Björn, this HTTP triggered successfully, and so on. This is plain PowerShell. I hope you all understand it. The other sort of half that makes functions different is the output binding. The output binding, again, like we don't have no console. So how do we return stuff? Well, we have a name response and says direction out. So we push our response out. And since we're using HTTP, we probably would like to have HTTP responses. You know how if you have ever looked into a header of a web page of any kind or invoke REST method, you have 200 OK in the very top? Yeah, this means 200 OK. So we need to say response is 200 OK, otherwise your browser or your caller will go bonkers and say something's wrong. You can also do errors and so on. So you can do error managing using the push output binding the same way and say, I can't find this user, or this user already exists. Again, standard methods of HTTP protocols, basically the same way you implement a web page. It's quite straightforward. And since we are doing a API, we can also post back the body. This should preferably be some kind of structured data, sort of JSON or something like that. Now you can, like I said, have one or more of these. When you do HTTP or web APIs, you can only respond once to the caller and say OK or error or whatever. But you could also add an output binding and saying, OK, start by adding this to my database. Push output binding to my database. And then push output binding to my storage account for logs. And then push output binding to my caller and saying, yeah, everything worked fine. You can only do one HTTP request though, or 0. You can now also remove this completely, and anyone who tries to call your web API will be ending up in an eternal loop waiting for 200 OK, which is hilarious. Destroying stuff for profit. Yeah. So, armed with some PowerShell, basically, and these two separate functions. Oh yeah, if anyone's curious, we don't often do using in PowerShell, but it's basically using system.net just means that we don't have to have system.net.http response context and system.net HTTP status context. That's all that first line does. You can remove it and add it down here if you want to. It doesn't matter. So, armed with a bit of PowerShell, I'm going to show you one of my most secret and cool modules that I've ever built. I have a module that I want to publish as a function. It's called invoke fruit API. Now this one, this is intellectual property. I will not share this with you because it outputs fruits, like fruit salad, serious business, mine, yep. You can also give it an -icons parameter, and it will output icons instead. See, this is really useful. This is why I keep it secret from everyone. It's really good, fruit salad. And we're going to publish this as an API. Now, as you may see, I just wrote invoke fruit API. This actually comes from a module that I've created. And I'm just going to go ahead and steal some code. Close your eyes, because there we go. There we go, and there we go. And again, pretty straightforward. We have our request. It supports the same input and output, gets and posts. In my code, well, I only care about the query parameter, so I'm just going to go for the query icons because too much code. And we're going to run the invoke fruit API depending on whether or not we have an icons query string involved. Last but not least, we're going to output either fruits or icons as the response, as JSON, because structured language, and return this to our caller. Now, there is one small detail here. This. So remember I said you have the managed this sort of stuff. Now, like I said, the fruit API, my intellectual property, it's secret. I haven't published it to the gallery because people would steal my code. No, because there is a simpler or actually smarter way to do this in some cases at least. So I have, oh, wait, a module, that I should copy the right way and paste. I have a module called basic function, which includes one function, that is the fruit API. And if I post anything inside the modules folder in the root of my project, this will automatically be added to the PS PS module loading path, which means I can just include the entire module in here. And this is good because partially we get automatic loading. We don't have to do the managing and downloading every cold start. It's already there and so on. But if you are doing web API development, you are probably going to want to lock down on versions anyway and verify that the version of the required modules that you want are actually okay to use. Partially because stability, but also because every now and then, just saying, give me the latest AZ module, well, every now and then things breaks or we have security holes and stuff like that. When you do this, you need to start thinking security-wise of sort of locking down your dependency tree as well. So downloading your modules and adding them to a modules folder let you do this. And then since we have the func CLI, if you want to update, just download the new version of the module, verify everything works okay, and then you can update it in here and push a new version. So the modules folder, magic folder, automatically mounted. So, awesome. I think we're done. I think this should work. Now, we haven't verified it. Had I run the func CLI, I could actually try this out already and see that it behaves the way I expect. But because testing stuff is boring and pushing stuff is fun, we are going to go back to our Azure Functions plugin. Now, as I said, you have your local projects down here, and if you keep track of it, I had 2 when we started and 3 now because we have created a new Azure Functions project. And we have my function in here, which currently, or function app, which currently have no functions. It's empty. But this also adds the deploy to function app functionality. So if we just right-click the function app that we just created, we click deploy to function app, we need to select which one we are deploying because again, I have 3 different in here. And hopefully, yep, it will ask, are you sure? Because this will hardcore overwrite whatever functions you are currently running, which means whatever you have in your folder right now, if you have a function up there running that isn't in your folder right now, that function is gone. Which of course is what we want, because hardcore deployments to main is cool. So, while this deploys, let's just do some, there we go. So what is happening in the back end? This. Deploying an Azure function is pretty simple actually. It's a lot of magic going on in the background, but the baseline of it is that it will take your folder, it will zip it to a zip file, and it will post it to an API on the internet, which I don't give a crap about what it does, because again, this whole idea is throw my code at it, and it works. It's just magic behind the scenes. So hopefully, we can, nope, I need to remember to click escape. Okay, go back here. No! Okay. It failed. Good thing I have a backup. Normally, this should work. Anyhow, I did this not too long ago, and it actually did work. So, like I showed you before, we have your function app, and inside, if you go back here, you have your functions in a list down here. Now, since my just recent deploy apparently didn't work, I don't know if my connection is bad, or if my login is bad, or if my code is bad, or whatever. Let's show you my previous one. Once you have deployed a function, it will look something like this in here. It's actually quite boring to look at, but you have a small button here. It says get function URL. I have it camouflaged because of a plugin, but there is a URL behind this, I promise you. If it would have worked, you would also have seen the same thing in this log. This is the URL to your deployment. And if we copy it, so you can see the naming structure. This is the reason why you need to have a globally unique DNS name, because this name is publicly reachable. You can browse to this if you want to any second now. And you have your you have your /API, and you have the name of your function that you just deployed. Would have been my function. In this case, is HTTP trigger, because I was too lazy to change the name of it. And if we just run it straight up, it will output run without parameters, apple, banana, kiwi, because I didn't have any query string to it. And I can also do something like icons equals true, and it will output icons instead. Now, there's one thing I actually did wrong when I did this deployment earlier today, and that is that I forgot to convert it to JSON. It should be structured, JSON standards or some kind of structured data. You can do text as well. In fact, you can actually do this, as you can see, and build web pages in it. I've built entire web pages in Azure Functions. They are dirty and kind of slow, but it works. You can do all kinds of cool stuff in this Azure function. And it's just PowerShell. So yeah, cool stuff, cool stuff. Now then, where were we? Oh yeah. You also have some monitoring that you can go in here and see sort of how many executions, what went wrong, if something goes wrong, which something hopefully shouldn't do, but apparently did. Yeah, you can see sort of the execution history, and you can see what goes on. You can also go in here and actually see the code, and you can run tests with different parameter values or different post bodies. So we actually have a test window somewhere around here. I'm just getting too nervous to remember anything. There we go. Where you can say, post this, post that, or you can try out your API in here, see and validate that it works. Of course, all of this is also doable through APIs, so you can write proper integrations tests and so on and so forth. Okay, so we have deployed our Azure function using PowerShell to our code using Bicep and all other cool stuff. Now, of course, we do not want to do this automatically, right? Everyone in this room should know that if you have done the same thing twice, you have done it once too many times, and it's time to automate it. So before all of this is done, we're going to look at one more thing. There are two ways of deploying stuff to this that's actually somewhat more useful. You can actually do the whole right-click deploy and right-click deploy, and as long as you have proper Git specific tracking and so on set up, it's workable in a smaller team if you can just tap your friend on the shoulder and ask, hey, is it okay if I update? But we can also use something like the deployment center. The deployment center allows you to connect an Azure function straight into a Git repo of your choice. It will create a, I want to say service connection, but that's not the connection string. Connection string that this one will, a webhook. That's the word I'm looking for. A webhook that one will hook into, so whenever Git updates comes to the branch of your choice, it will automatically just go and do the whole zip push, whatever. This works. It works quite decent, assuming you have set the storage. Remember I showed you the out-commented, If that one set correct, that might actually be the one that I did wrong in this. Anyway, if that one set correct, this one actually works quite well. But I, for one, do not like magic. I like pipelines. So to end all of this, this is kind of how we can do this automatically. So we started by doing bicep deployments, setting this up, creating our bicep. And bicep is a, not stateful, but state aware. Or like it keeps track of changes in Azure, and it can do the whole what if deployments and see what changes and so on, which means we can just have the sort of bicep files in the same repo if we want to, or separate repos, and just make sure, because as long as nothing changes in the bicep configuration file, and the state of the bicep configuration file is the same as the one in Azure, it will just go, oh, everything's fine and dandy, and I'm happy, I'm just gonna ignore the rest and move on. And as we just saw, the whole content of deploying an Azure function is creating an archive, a zip file, and then pushing it to an Azure function. Both of these steps are built in Azure DevOps, and they are also available as GitHub Actions, probably in every other functionality or every other pipeline runner as well. But again, like I said, I do not like magic, and this still doesn't really tell me what's going on. So naturally, we can also do this the long way around. Installing the required tools, because we need to create an Azure resource group using AZ-CLI instead, and deploy bicep file using AZ-CLI instead. And there's an AZ function app deployment source config zip, yeah, that one that you can do to run AZ-CLI to deploy all of this as well. This would be incredibly easy to move around and change to whatever, and since it keeps track of what's going on, it's actually working quite well and quite stable for at least somewhat larger deployments. Now, doing this manually also lets you do stuff like setting up your internal pools, because I, for one, do not like to allow anyone and everyone to deploy to my machines. So I try to lock them down using, access control lists and so on. Managed identities, it's a God-given from Azure. So we can actually create our own internal runners and use managed identities to deploy this instead, so we don't have to keep track of usernames and passwords, and no one has to be responsible for anything, and we just keep track of our pipelines and everything works fine. All good? Woohoo! Thumbs up. Okay. So, what have we done? We have deployed or looked at the deployment center. You can use it, it works fine, and we have deployed using pipelines and different versions and so on. And with that, I am actually out of presentation material, and I even have 2 minutes to go. So we have time for questions. Yes! Any questions? Not everyone at once, please. Shoot. Oh yeah, sorry. The post part of I only demoed the query string of the one I deployed. Like I said, in this code, I did not implement the post part. I only implemented the query runner or the query string. But since I also have the post here, I could actually just do something like if $null equals icons, I could do icons equals request dot body dot icons, icons, that way. This way, if you didn't put it in your query string, I would check the body of your post instead. If you do a post, it will automatically map this into the body property of the request. And you can do this, there's also a request type, if I'm not, my memory isn't fooling me, where you can say like, okay, if the request type that you send to me is a post, go this direction. If it's a get, go in this direction. If it's the options type, go in this direction. So you can actually implement. The reason I didn't sort of opt to show you all of this and focus more on the sort of surroundings is because I realized that there were like 4 different sessions in this conference on designing good APIs. So I was like, okay, there are other sessions that you can watch to sort of realize the structure, but you can absolutely do this. The request and, for that matter, the trigger data, it's all documented somewhere. I have the link in my presentation material. It will be up on the GitHub sometime. So it's pretty well documented what kind of metadata you get. The only issue is when it comes to web APIs, it's unstructured. I can post whatever, but you have to take care of it in your function. Of course, as we see from many APIs that we use, we can actually check the body. If it contains this key and this key, then it's okay. But if it contains this key and foo, then it's wrong. And instead of doing this, we would say push output binding, status code, error. And then you would get a 4.0 whatever. Okay? Thank you. Shit, sorry. No, we have, yep, not yet.
Actually, I think you can use the API management service to, I guess, validate the parameters.
Oh yeah, absolutely. You can do APIM in front of this. API management is part of Azure. I assume that's what you mean. Yeah, it's part of the Azure infrastructure. You can put one of these in front of it and do even more cool things. But I would say the downside, so Azure Functions, if you use consumptions, is virtually free. I would say, like, I don't know how many times I run through these demos, and I have functions running all year around. And I think I spent like the most, like 100 Swedish kroners, which is approximately $10, $15, something like that, a month for it. Because you pay only per execution, and the first like N+1 executions are free. So yeah, but whereas API Manager does super cool front-end stuff. It's really, really good stuff. But you have to open the big wallet for it. It's costly. But if you are a company, do use APIM. It's brilliant. Thank you.